Good morning, students. Welcome to the new lecture of physics. I am Mayur Sharma and we are going to discuss about solved and unsolved examples of electromagnetic waves. Example 8.4. Light with an energy flux of 18 watt per centimeter square falls on a non-reflecting surface at normal incidence. If the surface has an area of 20 centimeters square, find the average force exerted on the surface during a 30-minute time span. So in this example, you can see that energy flux is given as 18 watt per centimeter square. Area of the surface is given as 20 centimeter square. And we have to calculate force for the time period of 30 minutes. So let us start solving this example by making list of given data. In this example, energy flux is given, which is nothing but intensity I, which is given as 18 watt per centimeter square. So this is equal to 18 watt over 10 to the power minus 2 meter whole square. So that will be equal to 18 watt over 10 to the power minus 4 meter square, or therefore we can say that intensity I is equal to 18 into 10 to the power 4 watt per meter square. Also, area of the surface A is given as 20 centimeter square, which is equal to 20 into 10 to the power minus 4 meter square, and time t is given as 30 minute, that is equal to 30 into 60 second. Now we know that intensity I is energy per unit area per unit time. So this implies that energy will be equal to intensity into area into time. Let this be equation number 1. Now the total momentum delivered to the surface is P is equal to U by C. Let us substitute value of U from equation 1 in this equation. So therefore we will get P is equal to U is I into A into T over C over C. Let this be equation number 2. Now the total force or the average force delivered or exerted on the surface is F is equal to P by T. Now let us substitute value of P from equation 2, that is IA over C. So therefore we will get F is equal to I into A into T over C into T. T will get cancelled. So therefore force F will be equal to I into A over C, which is equal to, now intensity in this example is given as 18 into 10 to the power 4 watt per meter square. Area is given as 20 into 10 to the power minus 4 meter square, and speed of light is 3 into 10 raised to 8 meter per second. 3 6 is 18, 10 to the power 4 and 10 to the power minus 4 will get cancelled. So therefore F will be equal to 6 into 20 is 120 into 10 raised to 8 will move up, so 10 raised to minus 8 Newton, or you can say that F is equal to 1.2 into 10 to the power minus 6 Newton. Now it is clear in this example that why we have taken intensity first. because we need to calculate force, and the formula for force is momentum over time. Now momentum is u upon c, so it is necessary for us to calculate the value of u first. Example 8.5. Calculate the electric and magnetic fields produced by the radiation coming from a 100-watt bulb at a distance of 3 meter. Assume that the efficiency of the bulb is 2.5% and it is a point source. So in this example, a bulb of 100 watt is given and we need to find electric field and magnetic field at a distance of 3 meter from it. Also, the efficiency of bulb is given as 2.5%. Now here efficiency means the output power of the bulb will be only 2.5% of 100 watt, which means that output power will be 2.5 by 100 into 100, and that is equal to 2.5 watt. This will be the output power of the bulb. Now also it is given that the bulb is a point source. So for a bulb as a point source, as a point source, it will radiate light in all directions uniformly. Light will be radiated uniformly in all directions. Therefore, at a distance of 3 meter, the surface area of the surrounding sphere will be A equal to 4 pi r square, and that is equal to 4 into 3.14 into 3 square. So therefore 4 into 3.14 into 3 square is 9, is 113.04 meter square. This will be the surface area. Now we know that intensity is energy per unit area in unit time, but energy upon time is power, so therefore this can be written as power over area. Let this be equation number 1. Also we know that intensity is epsilon naught c E square. Remember, we want to find electric field, so epsilon naught c E square. Let this be equation number 2. So comparing equation 1 and 2, or you can say that from equation 1 and 2, epsilon naught c E square will be equal to P by A. This implies that E square will be equal to P over A into epsilon naught into C. So therefore E square will be equal to, power is 2.5, area just now we have calculated 113.04, epsilon naught is constant, its value is 8.854 into 10 raised to minus 12, and c is speed of light, that is 3 into 10 raised to 8. So E square will be equal to 2.5 divided by 113.04, divided by 8.854 divided by 3 will be 8.326 8.326 into 10 to the power minus 4 whole over minus 12, 10 raised to power minus 12 and 10 to the power 8 will be equal to 10 raised to minus 4. So this term will get cancelled. So therefore E square will be equal to 8.326. So therefore E will be equal to root of this, root of 8.326, 2.885. So this will be equal to 2.885, or you can nearly write 2.9 volt per meter. So value of electric field will be 2.9 volt per meter. Now we also know that E square is E naught square by 2. So this implies that E naught will be equal to root 2E. So therefore E naught will be equal to root 2 is 1.414 and E is 2.9. So 2.9 into 1.414 is 4.1006, or you can write nearly 4.1 volt per meter. This will be the value of electric field. Now we know that the relation between electric field and magnetic field is the relation between electric field and magnetic field is E by B equal to C. So this implies that B will be equal to E by C. B will be equal to E by C. So therefore B will be equal to E is 2.9 by 3 into 10 raised to 8. So 2.9 divided by 3 is 0.9666 into 10 raised to minus 8 Tesla, or you can write 9.67 into 10 raised to minus 9 Tesla. This will be the value of magnetic field. Also we know that B square is B naught square by 2, or you can say that B naught will be equal to root 2 times B, or you can say that E0 by B0 is C. From that formula also you can find B naught. So here B naught is root 2 times B, that is 1.414 into 9.67 into 10 raised to minus 9. So 1.414 into 9.67 is 13.67 into 10 raised to minus 9 Tesla, or you can write 1.367 into 10 raised to minus 8 Tesla. This will be the value of magnetic field. Unsolved example 8.3. What physical quantity is same for X-rays of wavelength 10 to the power minus 10 meter, red light of wavelength 6800 Armstrong, and radio waves of wavelength 500 meter? So in this question we have to find the physical quantity which is same for all these three rays. I think in this example it should be given that all these waves are propagating in same medium. All radiations are propagating in same medium, or it should be given that all the radiations are propagating in vacuum. So for all the radiations, their speed in a medium will always be constant. So the speed of all electromagnetic waves is same in a given medium. So in this example, speed will be same for all the electromagnetic waves. Unsolved example 8.4. A plane electromagnetic wave travels in vacuum along z direction. What can you say about the directions of its electric and magnetic field vectors? If the frequency of the wave is 30 MHz, what is its wavelength? So in this example, a plane electromagnetic wave is traveling along z direction is given. We have to find the directions of electric and magnetic field vector. Also, the frequency of the wave is given as 30 MHz and we have to find its wavelength. Now, we know that we know that E vector cross B vector gives the direction of propagation of wave. E cross B gives the direction of propagation of wave. Here it is given that EM wave, that is electromagnetic wave, is traveling along electromagnetic wave is traveling along z direction, and hence we can say that its electric field its electric field vector will be along x direction and magnetic field vector will be along y direction, such that vector E cross vector V gives z direction, that is unit vector I cap cross unit vector j cap will give us unit vector k cap. Remember, it is possible that electromagnetic waves traveling along z axis, then its electric field vector may be along y axis and its magnetic field vector may be along minus x axis. So there are different possibilities, but we have assumed one in which electromagnetic waves traveling along z axis and electric field vector is along x axis and magnetic field vector is along y axis. such that it satisfies the condition that electric field vector, magnetic field vector and the direction of propagation all three are perpendicular to each other, as well as vector E cross vector B gives the direction of propagation of wave. Also, in this example, it is given that frequency of wave is 30 megahertz. So that is 30 into 10 raised to power 6 hertz, or you can say that this is 3 into 10 raised to 7 hertz. We have to calculate wavelength. Now, the speed of electromagnetic wave, the speed of electromagnetic wave, EM wave, in vacuum is given as speed of electromagnetic wave in vacuum is given as C is equal to lambda F. So this implies that lambda will be equal to C by F. So therefore lambda will be equal to C is 3 into 10 to the power 8, or frequency is 3 into 10 to the power 7. So therefore you can say that lambda is equal to 10 meter. This will be the value of its wavelength.